Hello and welcome to this video lesson. Our focus today would be to determine the equation of a straight line. Okay, as a review, we know that the equation of a line is in form y is equal to mx plus b, where y is the y coordinate, x is the x coordinate of any point on the line, m is the slope, and b, slope or gradient here, and b is the y-intercept. So to find the equation of the line, then there are two things that always stay the same. One is the slope and one is the y-intercept. So those are the things that we really need to find. And if we are given 2 points, we can do just that. So first thing we do is we use the 2 points to find the slope, and we already know the equation for the slope, and that's the change in y over change in x, or y2 minus y1 over x2 minus x1. So we can use that, and let me just write that in. So m is equal to delta y over delta x. And once we have the slope, then we can find the b value, because that's the only thing that's left. So if the y-intercept is already given, so if you, for example, if you have a point 0, 2 or 0, 7 that's already given to you, that's the y-intercept, so you know the value of b. So you can just write your equation in the form of y is equal to mx plus b, where you found the m from this step and the b value just looking at the point. If the y-intercept is not given to you, then you have to calculate b using one of your points. And we will demonstrate that through this example over here. This example says to determine the equation of the line that passes through points 1, 5 and 0, 4. Now, our first step is to find the slope of the line. So looking at our points, this is x1, y1, x2, y2, and we can determine our slope using delta y over delta x. We know that delta y is y2 minus y1, so that's 4 minus 5 divided by x2 minus x1, which is 0 minus 1. So the slope is negative 1 over negative 1, which is just equal to 1 when you simplify it. So we know that in our equation, y is equal to mx plus b. The m value is determined as 1, so y is equal to 1x plus b, or just y is equal to x plus b. Now, you can right away look at this point over here. We know that this one has nothing to do with the y-intercept, but this one, the x-coordinate is 0, and if the x-coordinate is 0, that means our y-coordinate is the y-intercept. So right away, we can actually solve this, and I'll just continue with green and say, since point 0, 4 is on the y-intercept, therefore b is equal to 4. So this can easily be solved because we already can recognize that this point is our y-intercept, or the 4 here is our y-intercept. So since we have b, then we can simply say y is equal to x plus 4. And in this case, our slope value was 1 from here, so 1x plus 4. And this equation now has our y-coordinate, x-coordinate, our slope of 1, and our b value of 4. Now, if you were not able to recognize that this is a point on the y-intercept, then you can actually calculate the b value using this method. So we know that our equation is just going to continue this step over here. We know that our equation is y is equal to, I'm just going to include the 1 over here, 1x plus b, because 1 is our slope, and I kind of want to keep it in just for the sake of demonstration. We can use any of the 2 points. So here I have 2 points. I have this point and I have this point. So it doesn't really matter which point you use, you will get the exact same answer. I am going to choose this point over here. It's a little bit more challenging in terms of numbers because usually you try to use a point that has no negative values and a point that has smaller values. So in this case I have 1 and 5, here I have 0 and 4. Both 0 and 4 are smaller than 1 over 5, so it would be more wise to use this point. But just for the sake of demonstration and the fact that it always works, I will use this point. And I will say use 0.15. And on this point over here, we have the x-coordinate. And oh, look, the x-coordinate is this value over here. And the y-coordinate, is this value over here. So we can then just plug in our y-coordinate for 5. So my y is 5. It's equal to, my slope value is 1. I determined that previously. My x value is 1. And I don't know what my b value is. That's what I'm trying to find. Now, once I have it in this form, I have one unknown and I have one equation. So I can actually solve for my b value. Just going to remove this one. It kind of looks like an equal sign. So to solve for b, I will simplify this first. 5 is equal to 1 times 1, which is just 1, plus b. And to isolate b, I have to subtract 1 from both sides. So I get b is equal to 5 minus 1, or just 4. And once I have my b value and I have my m value, I can just write my equation. I know that my equation is y is equal to mx plus b. I know that my m value is 1 and my b value is 4. And the most simplified way of writing this, 1 times any number is just itself. So in this case, it's x plus 4, and that's my equation. The steps you have to show in a question like this is, obviously you have to start with method mark for using the proper equation to find slope, accuracy in terms of plugging in the correct number, implied method mark, and accuracy mark for finding the slope. If the y-intercept is already given to you, you need to reason out that this point is on the y-intercept, therefore b is 4, and then you can just arrive to the final answer using this as an accuracy mark. If you miss that, then you have a little bit more work to actually get to the b value. So, and sometimes you don't have the y-intercept given to you, so you actually have to go through this process anyways. So you would have to actually say which point you're using. That's a method mark. You will actually then have to accurately, using proper method, actually plug in the values in and solve for your b value. And there's kind of like a implied method mark on how you solve for b. And once you have that, you need to put it back into your final form of y is equal to mx plus b, and in this case you get y is equal to x plus 4. Okay, here we have an example to determine the equation of the following line, and we are given 2 points and a sketch, and we can actually use those 2 points to find our equation. So you folks can actually pause the video and actually try to solve it on your own, and then resume, and then we can continue to take it up. Alright, so in this one over here, we can see that we have 2 points. So I will actually label the points as x1, y1, and x2, y2. So first step is to find the slope. The slope is y2 minus y1, so negative 5 minus 0 divided by x2 minus x1, which is 5 minus negative 3. So I get negative 5, and I get 5 plus 3 in the denominator, which gives me 8. So the most simplified way of writing this is negative 5 over 8. Just a quick check, you can actually see that the line actually has a negative slope, and I have a negative value over here, so just a quick check on the direction would be pretty helpful. Now, once I have this, I have to find the b value. You can see that I'm not given the y-intercept over here, so I don't actually have this point. So I would actually have to calculate for the b value. And once again, I will use one of the points that I have. In this case, I have 2 points, this one over here and this one over here. Usually when I pick the points, I try to pick one that doesn't have negative values. They both have something that has negative. And the second way of actually simplifying your work is try to use points that have smaller values of x and y coordinates. In this case, I have 5 and negative 5. Here I have negative 3 and 0. I like the 0. 0 is very easy to actually manipulate when we are using an equation to solve for something. So I am going to use points negative 3, 0. And I know that my equation, I'll just write my equation up here, y is equal to mx plus b, and my m is negative 5, 8x plus b. So in this equation, the y coordinate is 0 and the x coordinate is negative 3. So I will just plug in those values. 0 is equal to negative 5 over 8. My x value is negative 3 plus b. Once I have this, I know that 0 is equal to negative 5 over 8 times negative 3. Two negatives cancel out to give me a positive, and this is same as 3 over 1. So numerators multiplied by each other gives me 15, and the denominator is 8 times 1 gives me 8 plus b. Now I have to solve for b, and I have to do that by subtracting 15 over 8 from both sides. So I will get b is equal to negative 15 over 8. Alright, once I have this, then I can write my equation. So I know m is negative 5 over 8. I know that b is equal to negative 15 over 8. So my final equation is mx plus b. I know that my m value is negative 5 over 8. And I know that my b value is negative 15 over 8. So instead of plus, I'll just write minus 15 over 8. And I can box my final answer. So you can see in this question, we didn't really get anything with integers. Everything was fractions, and sometimes that's the case. So in terms of marks, or what steps we usually look for, method and accuracy mark is something that I usually look for in the grade that I teach, and implied method mark sometimes here, and finally inaccuracy. In this case, the method mark doesn't really apply, but sometimes you actually have to do some calculation and simplification. So I just included it in this example. You then have to use one of your points. It doesn't really matter what point you use. And here I use points negative 3 and 0. And then you are going to plug in the 0 into y, then negative 3 into your x, and then, so you need to properly insert the values in, and then you need to solve for the b value. So there's an implied method mark over there, and then an accuracy mark for actually getting your proper p-value. Once we have this, the final part is actually writing it into an equation. So you're just changing your m into -5/8 and your b into -15/8. So an accuracy mark for actually completing that step. Now, if you are trying to find the equation of the line for a horizontal or vertical line, it really depends on the situation and what the question is. But usually the best way to figure these ones out is to actually sketch the graph using the information and clearly showing one point in the equation of the line, and then use the sketch to demonstrate or determine the equation. So let's actually do an example. It will make a lot more sense once we do a few examples, and it will really solidify the idea. So the question asks us to determine the equation of a line that is horizontal and passes through point A, which has coordinates of 2 and 3. So again, we're determining the equation of the line that is horizontal. So first of all, we're going to do a little sketch over here, and our sketch will have our x and y coordinates. The line is horizontal and it passes through point 2, 3. So I will approximately show the location 2, 3 here. So this is point A, 2, 3. And the other set of information is that the line is horizontal. So I know that my line will be horizontal like this. So just in terms of review from previous lessons, if you have a horizontal line, your equation, you know that the y coordinate is always the same. So you can just write that since horizontal, therefore the equation, you know that y is always the same and y is going to equal to 3, and that is the equation of the line. So in terms of steps that you need to show, obviously you need to show some work. You can't just say the final answer. And the reason you can't just say that is because it says determine the equation and it doesn't say state the equation. If it had asked you to state the equation, then you don't need to show any work. You can just go to y is equal to 3 without any reasoning. But since it says determine, you need to actually show some calculation or some work. So the steps, one of them is to actually show a sketch with proper coordinates or proper axes. So in this case, you will need to show your x and y axes, and then you need to show at least 1 point. So 1 point proper line, and you need to kind of have some sort of reasoning over here. Since it's horizontal, then you don't even have to say that the y coordinate always stays the same. You can just say your final answer. Make sure that you are boxing your answer over here, or just writing a concluding sentence that, or you can just include this little bit here, but just make sure that you are boxing your answer and saying that the equation is y is equal to 3. And the reason for that is when you're sketching, a lot of times you have a lot of things going on within your graph, and it's a little bit hard to actually determine what your final answer is. And it's difficult for teachers or whoever is looking at your work to see what your final answer is. So you need to actually box it or explicitly somewhere say your final answer is y is equal to 3. Let's do 2 other examples. In this case, the first example says to determine the equation of the line that has undefined slope and passes through point -2 and 7. Alright, so first of all, we need to determine, it's not a state question, so we actually need to show all the work. and we know that there's a point -2/7, and we know that it has undefined slope. And if it has undefined slope based on our previous lessons, that means that it has infinite slope, meaning that it's actually a vertical line. So let's sketch this. So when we're sketching again, we need to have x and y axes. Point -2/7 is approximately here, so I'm going to put it down here and I'm going to label it as -2 and 7. We know that our line has undefined slope, meaning that our line is actually vertical. So I will draw that like this. And here you can actually reason it out and say, since vertical, therefore, so we know that it's vertical, meaning that the x value actually never changes over here. So x value is -2 here, -2 here, -2 over here. So since it's vertical, therefore x is equal to -2 is our equation of the line. In terms of steps, again, make sure you have your x and y coordinate system. Make sure that you are showing a point. Make sure that you have proper line with proper arrows. Make sure you are reasoning it, and make sure that you have a final answer. Now, this question over here says determine the equation of the line that is perpendicular to y is equal to 3 and passes through point n, 0, 5. So I am going to draw out or sketch my x and y axes. And we know that our point n is 0, 0 and 5, so 0, 5, I will just label this as n, 0, 5. Now, reading the question again, determine the equation of the line that is perpendicular to y equals 3. So we need to sketch y is equal to 3 first. And to do that, y is equal to 3 is actually a horizontal line. So this is y is equal to 3. So I have to label this. And it's perpendicular to this. So if it's perpendicular, that means it's a vertical line. I'll just draw it with green over here because it's a little bit more visible. If it's perpendicular, that means it has to go vertical to this. And this should be perpendicular. So since this line is vertical, we already know that one of its points is 0, 5, meaning that the x coordinate is always 0 along this line, meaning since it's a vertical line, therefore the x value is always equal to 0, and that is our final answer here. This question is slightly more involved than the previous question because you have to also draw out your other equation, which is y is equal to 3. So there is kind of a method and / accuracy mark for properly identifying this line. The points over here needs to be shown. You need to show that there's a perpendicular line to it, so it's nice to show the perpendicular line, your x and y axes. And you need to reason that since this line, well, you need to also draw this new line over here. It's a little bit hard when it's on the axis. And you have to say, since it's vertical, that means that our equation is x is equal to 0. We have now covered situations where you can find the equation of the line using 2 points, and we have covered situations where you might have horizontal or vertical lines and some other information, so you can kind of sketch it out and find it using your sketch. But there's one other situation where they might give you some information about a line and tell you that your line is either perpendicular or parallel to that, and give you one other point and ask you to find the equation of the line. So let's go through this example. Okay, in this example, we're told that to determine the equation of the line that is perpendicular to y is equal to negative 3x plus 2 and passes through point 40. So our steps are actually very similar to the past. Our first step is to find the slope. Now, to find the slope this time, I don't actually have 2 points. What I know is that my equation, I'm trying to find an equation of the line that is perpendicular to y is equal to negative 3x plus 2. So we know that, let's call our line A and this line B. So I'm going to label this one as line B, and our line will be line A. So slope of B is the coefficient of x. So line B has equation y is equal to negative 3x plus 2. And actually, let's sketch this out as well. I kind of want to show you what we are doing. So sketching out the situation, we have our x and y coordinate. We have a line which has equation of negative 3x plus 2. So plus 2 is its y-intercept. Slope is negative 3. It's pretty steep and it's negative, so I'm going to draw it like this. So this is kind of a sketch of y is equal to negative 3x plus 2. And we're trying to find equation of a line which is perpendicular to this, but it's going through the point 40. And 40 is approximately here. This is 40. So I'm trying to find equation of a line that is passing through this one. And it's also perpendicular. So this is kind of what I'm trying to find. This is line B, and this is our line, this is A. So slope of this line that's given to us, y is equal to negative 3x plus 2, will be negative 3 because that's the coefficient of x. So MB is equal to negative 3. And our slope over here, since it's perpendicular, that means that it is the negative reciprocal of this value. So since perpendicular, MA is negative reciprocal of MA, meaning that it's negative 1 over, instead of MA, I'm going to put negative 3. I have two negatives which kind of cancel out, and I'm left with 1 over 3 as my slope, which kind of makes sense. You can see that your slope for our line will be approximately, well, it will be much more shallower than this slope over here, so it's 1 over 3, that makes sense. And we can see that our line here, this new one has a positive slope, whereas this one had a negative slope. So we can see that our line has a positive slope. So that's a good check right there. All right, now that we found MA, we know that our equation is y is equal to mx plus b. This is for our line over here. So this is for line A. So y is equal to, I know that my slope is 1 over 3x. I just don't know what the b value is, and that's kind of what we have to find. Now, we are given another piece of information right here, and it says that our line is actually passing through point 40. So we're just going to use this set of information, use point 40, and I know that in this point, the 0 is the y coordinate, and the 4 is the x coordinate. So I can just plug those values in. 0 is equal to 1 over 3 times my x coordinate, which is 4, plus b. 0 is equal to 4 times 1 over 3 is 4 over 3. Then to isolate for b, I have to subtract 4 over 3 from both sides. So I get b is equal to negative 4 over 3. So then I have my b value, I have my ma value, so my final equation is y is equal to 1 over 3x minus 4 over 3. So to recap, what we did first is we determined our slope. This time we couldn't find our slope using 2 points, so we had to use the information given to us. So we reasoned out that since the lines are perpendicular, then MA has to be the negative reciprocal. So 1 mark for reasoning it out, 1 mark for an accuracy, and 1 mark for actually reasoning out that MB is equal to negative 3. So actually figuring out that the coefficient of x in this equation gives us the slope of b. We then figured out that our slope is 1 over 3, so we used the point 40, which was our other set of information, and we properly plugged it into our equation to determine the b value. So there's an implied method mark depending on the difficulty of the steps over here, and we found out that our b value is negative 4 over 3. So finally, our equation of the line, we have the m value here and we have the b value right here, so we can just put everything together to find our answer.